Hi guys, my name is Terry. In this video, I'm going to go through with you the additional mathematics form 5 textbook question for chapter 8 kinematics of linear motion summative exercise. Okay, if you enjoyed this video, can you like, subscribe, or leave us a comment? Okay, let's get straight to the first question. Okay, a particle moving along a straight line, from a fixed point O. The displacement function is given like this. So calculate the distance from point O when P is A. Okay, very simple. We have to first sub E with 8. Your displacement is 2, 8 power 3. I'm going to write 5, 1, 2, 3, where you can use 8 power 3 minus 24, 8 squared is 64 plus 90 times 8. Okay, we can use a calculator. If you're not sure, just use 2 times 512 minus 24 times 64 plus 90 times 8. I got 208. Yeah? The first answer is 208. Okay, second one, find the velocity when t is 1. Okay, before we find velocity, we know we have to differentiate displacement to get the velocity function. So my velocity function, when you differentiate 2t cubed, 3 times 2 is 6, copy t, reduce the power by 1, differentiate 24t squared, the negative times the 24 times 2, negative 48, copy t, reduce the power by 1. When you differentiate 90t, you get 9t. Now we substitute t with 1, my velocity is 6 times 1, which is 6. 48 times 1 is still 48. I don't want to write the bracket 1, just add them up directly. 6 minus 48 is negative 42 plus 90. I will get positive 48. Right. Okay. Now, find its acceleration when t is 3. To find acceleration from velocity function, we have to differentiate. Differentiate 6t squared, I'll get 12t. Differentiate negative 48t, I got negative 48. Now, when t equals to 3, my a is 12 times 3 minus 48. 36 minus 48 is negative 12. There you go. That's your answer for C. ms minus 2. Yeah. Okay, lastly, find the value p when the particles stop momentarily. Now, particles stop momentarily when v is 0. We're going to let the v here be 0. This is your v here. Now, notice it's actually easier to factorize if the number here is smaller. We can divide everybody by 6. 48 divided by 6, I'll get 8. 90 divided by 6 is 15. Factor of 15 is 3 and 5. So I'm going to put a b, 5, 3. They are both minus. This is a negative here and a negative here. So d is either 3 or 5. Yeah, two values when the particle stops momentarily. All right, moving on to question number 2. Okay, a particle moves along a straight line. Yeah, displacement function is given like this. So calculate the displacement when p is 3. Okay, so let's just substitute. It's very similar to the first question. When p is 3, s will be, put 3 inside. 3 squared is 9. 12 times 3 plus 2. 27 minus 36 is negative 9. And negative 9 plus 7 is negative 7. So can my displacement negative? Absolutely. But if they ask for distance, then your distance is just 7 meters. Okay, find the initial velocity. Initial velocity, before we find initial velocity, we need to differentiate s to get your velocity function. In this case, it will be 6t minus 12. Differentiate 3t squared, 6t. Differentiate minus 12t, get minus 12. 2 is a constant. When you differentiate, you get 0. Now, initial happens when t is 0. Let t be 0. We get a velocity, and your velocity is negative 12. Okay, lastly, find the constant acceleration. Now, we know if your displacement function is quadratic, when you differentiate, your velocity function will be linear. When you differentiate one more time, you get acceleration, and your acceleration will be just constant. Yeah, differentiate 60, you get 6. Differentiate minus 12, you get 0. Your answer is just 6 ms minus 2. Okay, simple. Let's move on. Question number 3, right? Okay, a laser cycle passing through passes a house to a shop. All right. along a straight pedestrian path. The displacement is given by this function. Find or calculate the initial velocity. Okay, again, to find velocity from displacement, we have to differentiate. When you differentiate, this will be 6e squared minus 18e plus 12. 3 times 2 is 6. Copy e, reduce the power by 1. I hope you guys are okay with differentiation. Yeah, it's not too difficult, right? Differentiate 9e squared, minus 18e, differentiate 12, you get 12. 12e, you get 12. Differentiate 6, you get 0. Okay. Now I need to sub in initial. Initial means e is 0. I put 0, 0. My v is 12. So it's 12 meter per minute. Okay, next I need to calculate the velocity when v is 3. Okay, very simple. We take e equals to 3, put it inside. My v is 6, 3 squared is 9. 18 times 3 plus 12. This is 54. Oh, this is minus 54. 18 times 3 is 54 as well. You're left with 12 meter per minute. It's the same value. Equals to 0 and 3 yield the same result. Okay, now the next thing is calculate the acceleration when t is 2. Well, to find acceleration, I need to differentiate my velocity. When I differentiate this, I get 12e minus 18. When t is 3, t is 2, my acceleration is 12 times 2 minus 18. 24 minus 18 is just 6. And we write meter per minute minus 2. Okay, next, calculate the distance traveled in the 7 minute. Okay, distance traveled in the 7 minute, we can just use S7 minus S6. Okay, I think I'll just here, Roman 4, distance traveled in 7 minutes is S7 minus S6. Okay, we're going to sub inside. 7 cubed is 343, 7 squared is 49, 12 times 7 plus 6, S6 is 2, 6 power 3 is 216, 9, 6 squared is 36, plus 12 times 6 plus 6. Okay, I have a way to calculate a little bit faster, not to say very fast, but a little bit faster. We just take the 2, take the difference between 7 cubed and 6 cubed. That means 343 minus 216. Okay, and then take the difference between 9 bracket, you put a 9 here, bracket, 49 minus 36. Yeah, you can actually just calculate mentally. Yeah, okay. 13, actually, the difference is just 13. And then take 12, 7 minus 6 is just 1, so I just plus 12. Now, don't bother adding the last one because 6 minus 6 is just 0, right? So I press equals, there you go. My answer is 149. Yeah, it's just slightly faster, yeah, to use this method rather than keying on the line in a calculator. Okay, next, sketch a velocity time graph. Okay, now if you want to sketch a velocity time graph, first of all, we need to know when does the particle changes direction. All right, so I need to do some groundwork first. I'm going to let v be 0, right? Okay, let this v be 0. Notice that we can divide everything by 6. So t squared minus 3t plus 2 equals 0. Well, factorize this. 1 and 2, right? The particle changes direction at 1 and 2. So it's important that we do this because we are drawing a velocity time graph. And in this case, a quadratic. For quadratic, normally for this chapter, kinematics, we normally will have the graph intersect the x-axis, or in this case, we call it the t-axis. So your graph should go down, up like this. Yeah. Okay, let me. Okay, I think it's okay. Let me draw nicely. This is better. T equals to 1 and 2. I need a bit more space. Yeah. Okay. Now let's draw the horizontal line. Okay. This graph has to go higher a little bit higher because. Okay, I think this is better. Because you intersect the x-axis at 2 values here. Now the first one will be at 1, second one is at 2. Now, you might want to move this a bit closer, as in we can move this line a little bit lower so it looks a lot nicer. And this is my y-intercept. Yeah, like this. So this will be, okay, I know it's going to stop at 4, right? We have to draw up to 4 here. We know this is 2, 1 is here. I know my graph could probably be better because I should probably move this a bit higher so I can draw 4 closer to the right. But it's just a sketch. It doesn't have to be perfect. Yeah, so don't worry so much about that. Now, we know that the particle starts when t equals 0. The velocity is 12. Yeah, look at this, 12 here. So I can map 12 onto here. Okay, now we know that the particle intercept the x-axis or t-axis in this case at 1 and 2, and it does have a turning point here. We can write this as 1.5. Okay. Well, how do I get 1.5? Well, either you let your a be 0, since I already have a here. My a is 12, e minus 18. I let it be 0. 18 divided by 12 is 1.5. Or you can just use a simple axis of symmetry. 1 plus 2 divided by 2, still 1.5. Okay. All right. Then we want to take this and start inside your V to find the minimum. This is a minimum point. So we take 6, 1.5 square, 18, 1.5 plus 12. Okay. I'm going to use my calculator. This is 6 times 1.5 square minus 18 times 1.5 plus 12. There you go, 3.5. So negative 1.5. You can write here is negative 1.5 or 1.5 up to you. Okay, I still need one more thing. I need to find what is my V value when B is 4. Okay, you can just replace this with 4. Okay, I'm just going to delete this, replace this with 4. All right, I'm going to move this over, replace this with 4. Okay, my answer is 36. So that means the graph will go all the way up here, up to 36. Okay, so this is a velocity time graph that represent uh, Elisa's journey. Okay, so it's might be ugly, but it's okay lah. Okay, so not the real issue. Okay, all right. So that's question number 3. I don't think this is very. I don't think it needs a lot of brain here. Okay, let's move on to question number 4. Right. A particle starts from O, move along a straight line, passing through point marked with x. Yeah, displacement from point O is 1.25. Acceleration is given by 10 meters per second minus 2. So determine the velocity function and displacement function. Okay, if you already know your acceleration is 10, that means if you travel with a constant acceleration, we need to find the velocity function. We can do that by integrating your acceleration. So this will be 10t plus c. Now, the question says it starts from O. Now, here's the thing. When we say starts from O, it moves on straight line. So we are making a simple assumption that it actually starts from rest, right? So when b equals to 0, b is 0, therefore your c is 0. See that? b is 0, b is 0, c is 0. My velocity function is just 10. Yeah, I found my velocity function. Now to find my displacement function, actually displacement function is s here, not a. We need to integrate velocity. Okay, so this will give us 10t squared over 2, 10 divided by 2, 5t squared plus c. Now the thing is, when you start the clock, the particle is at O. It starts from point O. So when t is 0, s is also 0. C is also 0. My displacement function is just 5t squared. All right. Next, find the time in second when the velocity and the velocity when the particle is at point x. Now, it is given that the displacement from point O is 1.25 meter at point x. Yeah, at point x. So we're going to take this displacement function s and replace it. Let it be 1.25 here. Okay, very simple. 1.25 divided by 5, I got 0.25. Square root 0.25, 0.5. Now you don't have to put a plus minus because t is positive, but time is always positive. So 0.5 second. So I got the time in second. Next, find velocity. Take this, stuck inside your v. My v will be 10 times 0.5. Answer is 5 meters per second. All right. Also fairly simple. All right, that is question number 4. Let's move on to question 5. Okay, a particle moves along a straight line from fixed point O. Initial velocity is 8. Acceleration is given by this. Calculate the velocity when t is 2. Okay, to find velocity function from acceleration, we need to integrate. Integrate 6 minus 60 dv. Right, remember, if you differentiate velocity, you get acceleration. You integrate acceleration, you get back your velocity. So integrate 6, you add a t60. This one would be 6t squared over 2. 6 divided by 2 is 3. So I write 3t squared. Then you have to put a plus c. Now, when you start the clock, yeah, the initial velocity is 8. When you start the clock, t is 0. Your v is 8. So your c is 8. My velocity function is 6t minus 3t squared plus 8. Okay, so this is my velocity function. But I'm finding the velocity when t is 2. We put t equals 2 inside. Your v is 6 times 2 minus 3, 2 squared plus 8. This is 12 minus, this is 12 as well. 12 minus 12, 0. You plus with 8 meter per second. All right. B. Find the displacement when t is 5. Okay, the problem is I don't have the displacement function, so I could integrate my displacement to get, integrate my velocity to get my displacement. Right, now you can also choose to integrate directly. You can actually integrate 0 to 5 directly. Okay, anyhow, I'll just show you the displacement first. Integrate this, you get e power 2. 6 divided by 2 is 3. e3, 3 divided by 3 is 1, so it's e power 3. Integrate 8 is 8e plus c. Now when you start the clock, the particle starts to move at point O. So we know that when t is 0, s is 0, c is also 0. So my displacement function is now this. Okay, next, I need to sub in when t is 5. Where is the particle? Well, s is 3, 2 square, 5 square is 25, 5 cubed is 125, 8 times 5. So this is 75 minus 125, which is negative 50. Negative 50 plus this is 40, so it's negative 10 meter. My displacement can be negative, yeah, so its answer is negative 10. Well, we can also use integration like this. So you can say integrate 0 to 360 minus 3t squared plus 80t, right? So this is a definite integral, so you get 3t squared minus t cubed plus 80. Just sub in the limit inside, you will still get negative 10. Yeah, same answer, slightly different approach, because here I show you that we find the displacement function first, then we sub in these 5. This one we just integrate and sub in directly, right? All right, that is question number 5. Okay, let's move on to question number 6. All right, a particle move along straight line. The velocity function is given like this. Calculate the velocity when a particle stops momentarily. Okay, we know the values of t. Values of t when the particle stops momentarily. We know particle stop momentarily when your v is 0. So I'm going to let v be 0. Let's factorize t 3, 1 minus minus. T is 1 and 3. So there are two values of t when the particle stops momentarily. Now then find the distance traveled from 0 to 8. Okay, before you find the distance traveled, I'd like to do a sketch of the graph, the velocity time graph. Okay, now I can see that it's a minimum graph because my a here, my coefficient t squared is more than 0, so it's a minimum. And it will intersect the x-axis, or in this case, the t-axis at 1 and 3. But the question wants to go all the way to 8. Wow, that's very big. So I just do a sketch of the 8 here. So we know we have to find 3 parts to it. First part, 0 to 1. Second part, 1 to 3. Third part, 3 to 8. Now you can use definite integral. That means you integrate 0 to 1 because velocity time graph, the area under the graph represent the distance traveled, total distance traveled, but you have to integrate 3 separate parts. All right, 0 to 1, 1 to 3, 3 to 8. But I'm thinking in this case, perhaps I just sub in my displacement function because there are a lot more values to calculate, right? So maybe we find our displacement function first, then we sub in one by one. It probably saves us like space to write a lot of things, right? So I'm just going to write t cubed over 3 Integrate this is t squared, 4 divided by 2 is 2, integrate 3 is 3t plus c. Now we know that when we start the clock t is 0, the particle starts from fixed point O, so s is still 0. Your c will be 0. Picture this, s is 0, t 0, 0, 0, c is also 0. So this is my displacement function. Okay, now I just want to clarify this. Drawing this is not necessary. It's just useful. We know that to help you to understand, we know the particle starts from point O. Well, the particle probably go to the right-hand side first. I know it's going to go to the right because the velocity is positive, right? So it goes to the right. Probably make a U-turn at t equals to 1 here, right? It makes a U-turn, t equals to 1. Okay, and then it goes to the left. Now, the problem is it continues to make a U-turn here at t equals to 3. I don't know where is it. Somewhere here. Then it starts doing another U-turn. Okay, you can draw over here. It goes all the way until t equals 8. Now, we don't know where is t equals 8. Okay, so maybe I just label here. I don't know, maybe here. All right, so first we need to find the 3 important values. 1, 3, and 8. Yeah, these are the 3 different key points because if they change direction at 1 and 3, and we want to measure what is the distance traveled until 8. So since I already have my displacement function, I want to make full use of my calculator. Now you can actually type a general function in your calculator like this. This is alpha x cubic. I divide by 3. I minus 2 alpha x squared here, and then I plus 3 alpha x. Okay, let's calculate. Pick a number. Let's start with 0. I know 0 is going to be 0. Actually, you don't have to do that. 0 is going to be 0, right? As 0 is going to be 0. As 1 is going to give us 4 over 3. Okay, maybe I write here. As 0 is 0. As 1 is 4, 3, or 1, 1 over 3. I happen to like mixed number more than improper fraction because mixed number makes more sense to us. 1 more 3, we know it travels slightly more than 1 meter. All right, next, let's put 3 inside. I got 0. Oh, that means the particle actually returned to point O when t equals to 3. Okay, next one, I'm going to put 8 inside. I got 200 over 3, which is 66. This is S8, 66, 2 over 3. Well, I would have to do some changes to my diagram because you notice it actually didn't go to the left-hand side. It remains on the right. Okay, so your diagram, okay, let me draw or sketch for you once again. It actually starts from O, it goes to the right. All right, it started from point O, it goes to the right. It makes a U-turn here at 1 over 3 when t equals to 1. It starts to go to the left here at t equals to 3. Now at s t equals to 3, although it returns to point O, it is still making a U-turn, right? So it's going back again to the right. At t equals to 8, it is 66, 2 over 3 meter away from point O. So your total distance, we can do it this way. We can say, oh, my total distance is S1 minus S0. Now this one is going to be positive because it's going to the right. Then I plus S3 minus S1. This is going to be negative because it's moving to the left. And then I plus S8 minus S3. This is going to be positive because it's going to the right. Okay, now my S1 is very simple. 1 over 3. S0 is 0. S3 is 1 over 3. Wait, my S3 is 0. So I need to put 0 here, modulus, minus 1 over 3. And then this is 66, 2 over 3 minus 0. Okay, basically it's 1 over 3 times 2 plus 66, 2 over 3. Yeah, I'm going, maybe I show you here. This is 1 over 3 here. I travel back another 1 over 3. Right, I go here 1 over 3, I go back 1 over 3, then I go all the way here. Since it starts from 0, this length is also 66 over 3. Yeah, pretty simple. So 1 over 3 times 2 is 2 over 3. When you add up 66, you think 2 over 3 plus 66 2 over 3, that'll be 69 1 over 3 meter. Yeah, that's your total distance traveled. Okay. All right. So let's move on to question number 7. All right. Now, in this question, a particle moves along straight line. You're given acceleration function a equals to mt plus n. Okay. A equals to mt plus n. Okay. Now, the particle moves with initial velocity of 30, experiencing a deceleration of 20. That means when t equals to 0, your a is minus 20. Okay, so can we sub inside? Your a is minus 20, your t is 0, that means your n is minus 20. Simple. Okay, I still need to find m, and then it says stop when t is 2. Now, when it stop, v is 0. But I don't have velocity function, so I need to integrate my acceleration function. Okay, now that I know n is minus 20, so I'm going to put minus 20 here, dt. So this will be me squared over 2 minus 20t plus c. Now, they gave us an initial velocity. Initial velocity is 30. So we know when t is 0, your v is 30. Yeah, imagine your t 0, 0. V is 30. So your c will be 30. And my velocity function is now this. Okay, let me write this down first. Now, next, we need to sub in. Sub in what? When t is 2, v 0. Yeah, it stops when t is 2. So I'm going to put 0 inside here, put 2 inside here, m over 2. 2 squared is 4. 20 times 2 plus 30. Now, this is going to give us 2m here. Minus 40 plus 30 is minus 10. So m is 10 divided by 2. Can I just write 5? 10 divided by 2. M is 5. So I've got my m. I've got my n. All right. Next, we are supposed to find displacement function of the particle. Okay, to find displacement function, I need to integrate velocity. Well, I know my velocity function actually. My m is now 5. Can you put 5 inside here? So this will be 5 over 2 t squared minus 20t plus 30 dt. So when you integrate, this is 5t, increase the power by 1, 3, divide by 3. 2 times 3, I can write 6 straight away. This is t squared, 20 divided by 2 is 10. This is 30t plus c. When t is 0, what's the displacement? Well, the particle starts from point B. So P is a reference point. So S is 0, C is 0. My displacement is 5 over 6t cubed minus 10t squared plus 30t. All right. Next, find the value of t when particle stops for the second time. Oh, we need to let our v be 0. We know my v here. We know the particle stopped the first time when t is 2. To find the second time, we still need to let the v, this your v here, or right here, we let it be 0. Oh, I don't like this number, very big number. We can divide by 5, or should I multiply by 2 at the same time? So we times 2 divided by 5. So I get t squared. Okay, 20 divided by 5 is 4, 4 times 2 is 8. 30 divided by 5 is 6, 6 times 2 is 12. Nice number. And we can factorize this. Your factor should be 2 and 6. Yep, both are negative. So t is just 2 or 6. But because the question says for the second time, the first time it happens when t is 2. So second time happens when t is 6. So we ignore negative 2, we ignore 2, we take t equals to 6 seconds. Okay, lastly, calculate the total distance traveled in the second second. Okay, actually you don't have to mention the words total. Yeah, just mention the distance traveled in the second second. We know that second second is from 1 to 2. Remember, distance traveled the first second is s1 minus s0. Distance traveled in the second second is s2 minus s1. Since the particle distance change direction between 1 and 2, we can just find the difference here. Well, I have my displacement function, so, well, I think we can just sub in s2 minus s1, put 5 over 6, 2 cubed is 8, 2 squared is 4, this one is 30 times 2, s1 is going to be 5 over 6, minus 10 plus 30. Okay, I think you can just use a calculator, right? Again, now you can use the difference method, like I said, show you earlier, 5 over 6. 2 cube is 8. 8 minus 1, I just write 7, because this is 8. You minus 1 here. All right, then second one, minus 10. 4 minus 1 is just 3. And then next, this will be plus 30. 2 minus 1 is just 30, 130. Okay, I've got 5, 5, 5, 6. You write in fraction, 5, 5, 6. Yeah. Okay. Mixed number is 5, 5, 6. Huh? There you go. That's your distance travel. You can even use a calculator to type one by one if you want. Okay. So that is question number 7. All right. Moving on to question number 8. All right. Okay. A marble moves along a straight line. T-second after passing through point O. The velocity function is given by this. Calculate the velocity when t is 2. Okay, very simple. When t is 2, v is 2. 2 squared is 4. I sub 4 inside. 6 times 2 minus 6. So this is 8 minus 12, negative 4 minus 6. Yeah, negative 10 meter per second. Okay, B, find the acceleration when v is 14. We take our v here. All right, we let it be 14. Bring to the left, 2t squared 6t minus 20 equals 0. I think we can divide by 2 to make the number smaller. This will be 10. A factor of 10 should be 5 and 3, 5, 5 and 2, 5 times 2 gives us 10. Since this is negative, the bigger number 5 is minus, smaller number 2 is a plus. Now, time is always more than 0. When you start the clock, t is equal to 0. Anything must be, the subsequent time must be more than 0. So t is 5 seconds. But this is not what I want, guys. I have not done yet. I need to take this and find my acceleration. So my acceleration function can be found by differentiating my velocity. In this case, when you differentiate, you should get 4t minus 6. Put 5 inside. All right, you got 20 minus 16. 20 minus 16 is 14. Oh, it's 14 ms minus 2. Okay. So let's move on to question number 9. Yeah. Okay. Now, Irma drives along a straight road. Yeah. After leaving a car park in shopping complex, the velocity is given like this after passing through the automatic bar. So the initial displacement is 50. Calculate the velocity when the car stopped instantaneously. Okay, the car stopped instantaneously when your v is 0. I'm going to let this v here, v is 0. I can multiply by 2 to get a fraction, so that's easier for us to factorize. Now here we have a common factor. I can take out t minus 4, right? So the car stopped instantaneously when t is 0 or t is 4, but we don't take t equals 0. Why? Because when they start, right, when she start to move, start to drive, t is 0. So we that is starting from rest. Yeah, it stopped instantaneously after it start to move when t is 4. Okay, B, find the distance traveled in the first 7 seconds. Okay, to find the distance traveled first 7 seconds, I guess it's better for us to find displacement function first, although you can integrate directly. Why? Because I see the second part, I still need to find out the distance. So in the first 6 seconds, maybe we find displacement function first so that we can use the displacement function once again in part C. So when I integrate this, I get t cubed over 6. This is t squared plus c. Now, when you start the clock, t is 0. But the car has an initial displacement of 50. So S is 50 or C is 50. My displacement is t cubed over 6 minus t squared plus 50. Okay, not done yet. Now we know the particle stopped instantaneously at 4. So for me, whenever you want to find the total distance traveled, it's good to do a sketch of the velocity time graph. Now we know that the graph goes from 0 here. It stopped instantaneously at 4, then it continue until 7 because you're finding the distance traveled in the first 7 seconds. So this tells us which part is moving. It's actually going to the left, then it goes to the right. Yeah, area below the t-axis. In this case, if it's negative, that when you integrate it's negative, represent motion to the left. Okay, so we know we have to do part by part, 0 to 4, 4 to 7, but we don't have to use definite integral because I already know my displacement function. So I'm just going to sub inside my displacement function. Okay, so the 3 key value, E0, we know S is 0. E equals to 4, we need to find what is your S value. And E equals to 7, we need to find what's your S value. You can write that as S4 if this is S7. Okay, let's just use our calculator. Again, I want to use the calculator function, alpha x cubed, right, over 6. Then I'm going to minus alpha x squared plus 50. I'm going to press calculate. Let's start with 0. No, 0 is going to give us 50. Sorry, it's not 0. Yeah, it's not 0, it's 50 because, yeah, initial velocity here is 50. Then you calculate with 4. I got this value, which is 44/2/3. Yeah, 44/2/3. Yeah, and the next one is calculate put 7. I will get this value, big number here, 58 1/6. Yeah, 58 1/6. Okay, now you can see that the car actually moved forward backwards first, then it moved forward, right? But we need to write down the maybe I do a sketch for you here. So it actually go from here 50, initial is 50, it goes backwards to 44/2/3. When t is 0 is here, when t is 4 is over here, then it makes a U-turn, it starts to go forward. When t equals to 7 is at 58 1/6. Yeah, so this is easier for us to see and understand. Now let's find the total distance. Your total distance will be, we can say S4 minus S0. And this part here is going to be negative, right? And then followed by S7 minus S4. My S4 is 44/2/3. My S0 is 50. You modulus it. My S7 is 58 1/6. You minus 44. No space. 44/2/3. This is 2/3 here. Okay, let's count. Now this will give us -5 1/3, but you can modulus it, becomes positive. All right, and this one, when you subtract, well, this will be 58. Okay, just use a calculator. 58 1/6. You minus 44. Okay, I need to use this. 44/2/3, and you will get 13.5. Right? So 13.5. You add up, you should get 18.5/6 meter. All right. Okay, next one. Describe the movement of the car in the first 6 seconds. Okay, since they want 6 seconds, so let's just find out where is the car when t is 6. Okay, I think we can sub inside. When t equals to 6, S6 will be. Now just use your calculator directly. Actually, I've done all that earlier. So let's do 216/6. All right, minus 6 square. This one is 6 square. 6 square is also 36. Well, you cancel each other out, right? And you will get 50, right? So that means that the car actually returned to the starting point here when t is 6. It just go back and then go forward. At t equals 6, it is back at where we started, right? So how do you explain? Okay, let me just rewrite this for you. Okay, we know that describe the movement. The car move backwards, or you can say reverses. Move backwards or reverse. Yeah, backwards for the first 4 seconds. Okay, 4 seconds. Correct. I think you don't have to mention. I think textbook answer they don't mention until it reaches 44/3. I didn't mention that, right? Since it's a very open type of question. They say describe the movement. So maybe they say you move back, move forward will do. All right. You can say the distance travel if you want. It travel 5, 1 or 3 backwards, and then move forward. It moves forward for how long? For 2 seconds. Yeah. You can say returning to its original position, to its initial position. Yeah, its initial position is at 50, so it moved back to 50. So yeah, so total time is within that 6 seconds. All right, let's move on to question number 10. Okay, a particle moves along a straight line and it passes through fixed point O. The velocity is given by this v equals d squared minus at. Show that maximum velocity of the particle is not zero. Okay, now this one is very um, confusing for some people, is that because they ask for maximum velocity. When you get this graph, right, this is a quadratic function. It doesn't have a maximum. It has a minimum, right? But if you want to answer the question properly, maybe we should say your A is your dV, right? When you differentiate, you get 2D minus A. And when you do a second order differentiation, you get 2. So it's more than 0. So when it's more than 0, that means V has a minimum value. But it doesn't have a maximum value. Yeah, so V does not have the maximum value. So now we can actually back it up by drawing a graph. You can see when t squared minus 8t equals to 0, t minus 8, t is 0 and 8. So your velocity time graph, velocity time graph looks like this. So it cuts the v-axis here at 0. This is at 8. Now it goes all the way up. So you never have a maximum value, and the maximum value is not 0. Yeah. So yeah. So we can say for t more than, if v is more than 0. So we say v, maximum value of v, maximum value of v is not 0, because you go all the way. Yeah, and the question never say where we stop. Yeah, when we want to find from t from what to what. So it goes all the way. If you want to say t can go all the way to v can go all the way to infinity. All right, second one. Find the displacement to the nearest meter when t is 4. Okay, so since you want to find displacement, I think we can just integrate. You can use definite integral straight away, or you can integrate to find the displacement function. So when I integrate this, I get t cubed over 3 minus, increase the power 1, 2, divided by 2, a divided by 2 is 4, 4t squared plus c. Now we know when t is 0, s is 0 because it passes through point O, your c is 0, my displacement function is now this. Okay, I use sub t with 4. So when t equals to 4, I put 4 inside. 4 cubed is 64. This is 4 times 4 squared, also 64. 4 squared is 16, so 64 here. So it's basically 1 minus 1 over 3 minus 1 bracket 64. Yeah, so it's 2, 3 times 64. 128 over 3. 128 over 3 is 42, 2 over 3. Okay, you can confirm. Yeah, let's see. 64 over 3. You minus 64 here. This is 4 times 16, 61. 128 over 3. There you go. 42, 2 over 3. But we are finding displacement. Can your displacement be negative? Can, right? But the question asks for displacement to the nearest meter. So we write negative 43 meter, this one to the nearest meter, right? The one nearest meter. All right. Okay. It's not too difficult. All right. Next one. Question 11. A particle moves along a straight line from fixed point or displacement of particle is given by this function. Express the velocity and the acceleration in terms of t. Okay, so let's differentiate displacement to get velocity. 3d squared minus 3. Okay, differentiate one more time. 6d. So you got your velocity function, we got your acceleration function. And just differentiate twice. B. Describe the motion of particle when t is 0 and t equals to 2. Okay, actually I got all three. I got displacement, I got velocity, I got acceleration. All right, so we can find all three. When t is 0, what is your s? Put 0 inside. Okay, you get 1, right? What's your d? Put 0 inside. I got minus 3. What's your a? Put 0 inside. My a is 0. Okay, but here the question says describe the motion. Actually, you don't have to mention about your displacement. I think a textbook answer doesn't write about displacement, but if you want, you can write all three, the SVA. So we can say the particle is 1 meter to the right of O, then is moving to the left. To the left. Yeah, it's moving to the left because my velocity is negative. To the left with, you can only speed of 3, but you can also say with velocity of -3 ms minus 1. All right, and then with acceleration of 0. Okay, acceleration of 0. It's not moving. I mean, it's not moving faster. It actually reach what you call that, acceleration of 0. All right, but we still need to find one more thing. The motion when t is 2. When t is 2, let's put 2 inside here. 2 cubed is 8. 3 times 2 plus 1. 8 minus 6 is 2. 2 plus 1 is 3. How about your velocity? I put 2 inside. 2 squared is 4. This is 12. 12 minus 3 is 9. 9 meters per second. All right. Okay, how about your a? 6 times 2, which is 12. 12 ms minus 2. So what can you say about the particle? Okay, well, the particle is 3 meters to the right of O. Okay, now it's moving to the left or to the right? To the right, yeah? To the right with velocity of 9 meters per second. That is 9 meters per second, right? And with acceleration, and with another one, and acceleration of 12 ms minus 2. Okay, so describe the motion. Yep, done that. And lastly, okay, now this question, I personally think is a bit, they shouldn't say time interval, they should say time in second when the particle changes direction. Or if not, they should say find the time interval when the particle is moving to the right. Because when you let v be 0, when the particle changes direction, you don't get a time interval, right? You get the exact value of t. So we already have our t value here. We can divide by 3. You can bring it over, or you can put the plus minus here. You can, okay, I think I'll just bring over, it's so much easier, right? You can just bring it over. T squared equals 1. T is more than 0, so t is 1, right? But this is not the time interval. It is the time, exact time when the particle changes direction. But if you want to say time interval, then we should say when the particle is moving to the right, okay, or moving to the left. In this case, because the textbook answer is based on t more than 1. So the particle actually moves to the right when v more than 0. So if you want to solve this, what will most people do? They'll divide by 3. They'll double bracket factorize t plus 1, t minus 1 more than 0. Let's sketch a graph. Minus 1, 1. Now we know t is more than equal 0. So t more than 1. Yeah, we don't take these two parts here. We don't take the negative part here. We take t more than 1. So yeah, like I said, the answer given is this. Maybe they should say the time interval when the particle is moving to the right. Yeah, then that would yield this answer. If not, they say find the time cross out the interval when the particle changes direction. When the answer is this one. Okay, that is for number 11. Let's look at number 12. Okay, now, so here we have, this is a very long question. Particle move along a straight line. The displacement velocity is given by this is in terms of h and k. Particle stop instantaneously after 3 seconds. That means v equals 0, e is 3, and the acceleration at the time a is 9. So here, when you have two unknown, we need to form two equations. So my first equation will be we sub v with 0, e with 3, 0 equals 9. This one is 3 squared, I write 9. This one will be k times 3. So bring over 3k is negative 9h, k is minus 3h. First equation. Okay, my second equation, I have used the acceleration, but we know to find acceleration, we need to differentiate velocity. So this is 2he plus k. Same thing, your a is 9 when b is also 3. So let's put 9 here. This is 2h3 plus k. So 6h plus k is now 9. This is my second equation. So I need to solve for h and k. Maybe I sub 1 in 2. My k is minus 3h equals to 9. 3h is 9. Oops, no space. H is just 3. As you sub inside equation 1, my k is minus 3 times 3 minus 9. All right, that is part A. Okay, part B. The time in second when the particle returns to its initial point. Well, its initial point in this case is point O. Now, a particle returns to point O when S is 0. But first, I need to know what is your displacement function, your S, right? So we know your H and K. Let's sub inside here. V is now, H is what? 3. T squared, k is negative 9t. To find displacement, we need to integrate your velocity. So this is t power 3 divided by 3. You cancel out 9 over 2 t squared plus c. Now we know when t is 0, s is 0, c is 0. This is pretty standard. My displacement function, okay, I'm just right here, s equals to t cubed minus 9t squared over 2, 9 over 2 t squared. Okay, we let your s be 0. We know the particle returns to point O or initial point when this is 0. I don't like the 2, I multiply by 2, I get 2t cubed 9t squared equals 0. Take out common factor 2 and t squared. Yeah. Sorry, just t squared. I can take out 2. Just take out t squared. So you are left with 2t minus 9. Now your t is either 0 or 9 over 2. 9 over 2, you can say is 4.5. Now we can't take t equals 0 because return. So you don't take the initial value, t equals 0. Now you want to take this and use this result, this 4.5 second, right? Use the result to find part C. Now in part C, you're finding the acceleration when it returns to the initial point. That means we need to take 4.5 or 9 over 2, sub inside your A. But I got my A actually, right? Okay, but I think it's easier to take this and differentiate. A is 6e minus 9. Let's put 9 over 2 or 4.5 inside. Cancel, 3. 3 times 9 is 8, 27. 27 minus 9 is 18 ms minus 2. Oh, this is very long. Lastly, total distance traveled in the first 5 seconds. Okay, do we know the time when the particle changes direction? Yes, we do. Yeah, v equals 0, t equals to 3. Okay, so, and you can see from here as well, right? Yeah, there's no other time when the particle changes direction. It only changes direction once when v is 3. Yeah, so I don't think we need to write v equals 0 or solve for that because we already know v is 0 when v is 3. So since I know my displacement function, so we can just find the difference. Okay, picture this. Okay, I'm going to draw over here, more space here. Now, initially, the particle moves to the, let me see, it moves to the left because V0 is a minimum graph, right? It goes to the left. It makes a U-turn when T equals to 3. Then it starts to go to the right. Maybe here, I don't know, T equals to 5 here. Right, we need to find out. Okay, now, so the main thing is to find the difference between these two values. This is your S3 minus S0. This is your S5 minus S3. We need to find this. Okay, since I already have my displacement function, so my total distance will be S3 minus S0, S5 minus S3. Now the S3 minus S0 part will be negative, so I'm going to modulus it, right? Okay, well, I'm going to use my calculator here. Okay, let's key in this function, alpha x cubed, right? And then minus 9 over 2 alpha x squared. Press calculate, pick your S3. Maybe I write down my S3 here. My S3 is, let's write down, calculate. S3 is negative 27 over 2. 27 over 2 is 13.5. Then I calculate my S5. S5 is 12.5, 12.5. You can write S5 as 12.5. Okay, now that means the particle actually moved to the left by 13.5 here. This is negative 13.5. Then it moved to the right, reached 12.5 here. So this is negative 13.5. As we know, S0 is 0. Yeah, S0 0 and T0, S0 C0. So S5 is 12.5. You minus negative 13.5. So this is 13.5. This one you can add up. It is now 26, right? Yeah, because you go 13.5 to 0, then you go to the right some more by 12.5. So total distance to the right is 26. You add with this, we get 39.5. Now, I think the textbook gave a different answer. I think the answer in the textbook is 14.5, which is I think it's incorrect. You can validate, verify. Yeah, I got 39.5. All right, that is question number 12. Let's move on to 13. A few more to go. Now, a particle moves along a straight line, passes through a fixed point O, velocity of -6. Acceleration function is given. Find the maximum velocity. We've done a lot of this, right? Maximum velocity happens when A is 0. Okay, so I'm going to let A be 0. 40 is 8. A is 2. Now you take this and sub inside your V, but I don't have V. I don't have the velocity function, so I have to integrate my A to get my V. So this is 8t minus 2t squared plus c. Remember, t squared over 2, cancel, get 2. When t is 0, what's your velocity? Your velocity is -6. So my c is -6. My velocity function is now this. Okay, now take t equals 2 and sub in. That will give us a maximum velocity. Put 2 inside. 2 squared is 4. So this is 16 minus 8, which is 8. 8 minus 6, you get 2. That is my maximum velocity. All right, next, find the time in seconds when it passes through fixed point O again. Well, to find the time it passes through fixed point O, I need to let S be 0. My displacement is 0. But I don't even have displacement function. So I will integrate my velocity function. This is my velocity function. So as we integrate this, you get 4t squared divided by 2. E divided by 2 is 4. 2t cubed divided by 3. 6t plus c. Okay. Now, I need to let t be 0, s be 0, c 0 to find my c value, because it starts from point O when you start the clock. B 0, s 0, c 0. My displacement function is now this. Okay, we let s be 0. Okay, let S be 0. So to solve this, I don't like the fraction, so I times 3. And I notice 4, 2, and 6, they are divisible by 2, and I see a negative in front. So I would times with negative 3 over 2 just to get rid of negative, as well as I can divide all by 2. So now, when you take negative 2 over 3 divided by 3, negative 3 over 2, or times negative 3 over 2, you cancel this out. You're left with e power 3. Or you divide by 2, you get 2. 2 times negative 3 is negative 6. Negative 6, if I divide by 2, I get negative 3. 3 times 3 is a positive 9 here. Let it be 0. So what we can do is we can pick up b. This will be a quadratic inside here that you can factorize it. Now this is in the form of a squared plus 2ab plus b squared, which you can factorize quite easily, a plus b squared. So in this case, it's b minus 3 squared. Your b cannot be 0, b has to be 3. Why cannot be 0? It passes through fixed point O again. It started from fixed point O when t is 0. It passes through fixed point O again when t is 3 seconds. Okay, now we want to sketch velocity time graph. Okay, now this velocity time graph is not typical. It is quadratic, but you notice negative here, right? Maybe I would let b be 0, 8t minus 2t squared minus 6, let it be 0. I will divide by minus 2 just to make it easier for me to factorize. Okay, 8 divided minus 2 is minus 4, minus 6 divided minus 2 is positive 3. When you factorize, t is either 1 or 3. T is 1, t is 3. Okay, so next, I know the graph, it must intersect the t-axis at 2 points, but I know also that the v has a negative coefficient. It's a maximum, right? And the question already mentioned the maximum earlier that we calculated is 2. So when I sketch a graph, it should look like this upside down. It goes like that. Okay. Okay, but we only want to draw until 3. So a maximum of 3. So I think anything more than that, my button. Oh, I cannot draw like this. It's very ugly. Need to use a ruler. This one is 3. This one is 1. Extend this a little bit. Draw this line here. Okay, could be better. Yeah. I think my graph is a little bit too big. Don't draw so big. All right. This one goes down like this. Okay. Oh, my line is not so straight, man. And then horizontal like this. Okay, certainly can be better, right? Yeah, you can see that it's like, whoa, so ugly, right? So okay lah, I will just take this as it is. This is 1, this is 3, this is t, this is your initial velocity. Now we know our initial velocity is -6. See this? -6. My maximum velocity is 2. This is your v, this is 0. And that happens if you take 1 plus 3 divided by 2. We already know this is 2, right? See? The maximum happens when t is 2. So I just label 2 here. Well, my graph is done. Right? Velocity time graph is done. Okay, I just have to find last part, total distance traveled. Now, you don't have to use a definite integral, yeah, integration this or this is area under the graph, because I already know my displacement function. Yeah, this is my displacement function. Basically, I just have to sub in. Okay, but we can see that the total distance is, you have to take the difference between what? S1 minus S0, S1 minus S0, 1 to 0, and then S3 minus S1. Now the S1 minus 0, S0 is going to be negative, so I modulus it. I know it's going to be negative because it's below the t-axis. Yeah, if we integrate, you're going to get negative value. Now, let's not do too much work. I'm going to key in my displacement function here for alpha x squared minus 2 over 3 alpha x cubed, then I minus 6 alpha x. First calculate, pick a number. Let's start with 0. 0 is going to be 0, right? You're going to put 1. 1 is going to give us -8 over 3. -8 over 3 is 2 over 3. Yeah? Okay, maybe I write here This is -2, 2 over 3. This is going to give us 0. Let's find out what is S3. Okay, calculate, put 3 here. I got 0. Well, in fact, I already know. It returns the point out here when E is 3. Yes. So this is going to give us 0 minus 2, 2, 3. So you add up, you get 2, 2, 3 times 2, 5, 1 over 3. Now, if you want, you can actually draw this, use this as a guide. We know that the particle starts from point O, it goes to the left, it makes a U-turn when E is 1, and this distance is 2, 2, or 3. Then at it starts to go to the right, at T equals to 3, it returns to point O. So the distance traveled is just 2, 2, 3 times 2. That's 2 times of this, right? So, yeah, and your answer is 5, 1, and 3. Yeah? All right. Okay, let's move on to question 14. All right. Teacher Aziza conducted an experiment to determine the velocity of trolley along a straight track. So the velocity is given by this function. So find the initial velocity. Okay, very simple. Initial happens when v is 0. We put 0 inside these two. My v is just 6. In this case, it's cm. So I'm going to write cm per second. Okay, next, this is Roman 1. Roman 2, the range of time in second when the trolley is moving to the left. Now we know trolley moves to the left when v is less than 0. So we are going to take this. Okay, let me write one more step. E squared minus 7e plus 6 less than 0. Let us double bracket factorize this, 6 and 1, minus and minus. Let's sketch a graph. The roots are 1 and 6. It's less than 0 when the region is below. So you can highlight this is here, right? More than 0 is this 2 and less than 0 is below. So we highlight and shade this region. So T is between 1 and 6. The range of time is between 1 to 6. Okay, next one. The range of time when the acceleration is positive. So we have to differentiate V to get your A. Differentiate t squared, I got 2t. Differentiate minus 7t, you get minus 7. Differentiate 6, you get 0. My acceleration is now positive more than 0. t is 7 over 2. So there you go. There's a range of time when acceleration is positive. Now next, I want to sketch the velocity time graph. Now we actually have the velocity time graph here. Just draw a bigger version. And we're drawing up to 6. So let's do a bigger sketch like this. Whoa. Okay, now this is a bit too big. Okay, sorry, my line is still a bit ugly. I need to draw a nicer looking graph. Okay, this one looks a little bit better. So let's draw this axis here. All right, because I need to draw 1 to 6. 1 to 6, so it's here perhaps. All right, and let's extend this a little bit. Can I a bit like this, huh? Okay, let's just go all the way up. Now we know when we start the clock T, V is 6, right? So this is 6. This T equals to 1. This T equals 6, right? Okay, we're supposed to draw from 0 to 6. And we know it has a maximum acceleration when A is 0. Now don't recalculate because you see, when A is 0, what's your T? Your T is 7 over 2. Or you can use axis of symmetry. 1 plus 6 divided by 2 is 7 over 2. So what we need is the minimum velocity. So take this and substitute your V, you get 7 over 2 squared minus 7 times 7 over 2 plus 6. I'm going to use this, calculate this mentally. 49 over 4 minus 49 over 2. So it's negative 49 over 4 plus 6, right? So, oh, I'm right. Yeah. Can you simplify that? This is 12, right? 12. 48 divided by 4 is 12. So it's 12, 1 over 4 plus 6, 6, 1 over 4. Yeah, you can use a calculator. 6, 1 over 4 looks like this. So I guess my Graph is complete. This is a minimum velocity. Okay. All right, last question. Question number 15. Okay, a particle moves along straight line. Velocity function is given. Particle stop instantaneously at point P and R. Find the minimum velocity. Okay, minimum velocity happens when when A is 0, but first we have to differentiate your V to get your A. I let A be 0. I solve for P. 6 divided by 2. Can I write 3 straight away? Yeah. Okay, take this and sub inside my V. I already know my velocity function, so no need to recalculate. 3 squared, we can write 9. Now this one is 9 minus 6 times 3 plus 8 minus 9 minus 18, negative 9, negative 9 plus 8 is negative 1. Okay. Now the particles stop instantaneously at P and R. We know it stopped instantaneously when V is 0. Let's take this V here. Let it be 0. Double bracket factorize them. E, this should be 4 and 2, 2 and 4, minus and minus. So T is 2 or 4. Okay, now we need to take this 2 and we need to find the distance. Now, since I look at the next part, I don't have to find total distance, right? So I think maybe just use definite integral straight away. We don't have to find displacement function, right? We know at PT is 2, at RT is 4. So the distance between them should be the integration of 2 to 4 VDD, because this is the minimum graph, right? Yeah, we're going to draw the graph later on. So this is 2, this is 4. It looks like this. The distance traveled is this to 5. All right, so we integrate t squared minus 6t plus 8dt. So the moment you integrate, this is d power 3 over 3. Increase the power by 1, 2. 6 divided 2 is 3. This is 8t to the 4. Okay, let's put 4 inside. 4 power 3 is 64. 4 power 2 is 16. Put 4 inside here. 4 times 8, you can write 32. Minus, put 2 inside. 2 power 3 is 8. Put 2 inside. 2 squared is 4. 8 times 2. Okay, now you can use your calculator. This is the best part of the calculator. You integrate. Copy your x squared. Oh, sorry, this is x squared. Then minus 6 alpha x plus 8. Lower limit is 2, upper limit is 4. Oh, you got negative 113. Now, don't be surprised if you get a negative answer. We got negative answer because previously, when I sketch a graph, you can see it. This is below, this is a minimum graph. This area is below the x-axis. It's actually moving to the left. That's why the displacement or the distance, it looks like negative, right? It's okay. We can just say distance is positive. VR is just 1/3 meter. Yeah, you got negative because it's moving to the left. Okay, lastly, sketch the velocity time graph. But this time I'm drawing from 0 to 7, right? So we got 2 to 4. It looks like this. 0 to 7 looks like I'm going to go down and up. Okay, so let's just add this line. Okay, maybe I move this higher a little bit, right? And I draw here, okay, and add the vertical line. Hope it's not too ugly. All right, so this is 0, this is 2, this is 4, this is 7. T here. Okay, we need to find a couple of things. Number one, we know the turning point is at 3. See, t equals to 3. Minimum is -1. We already know all this thing. Initial velocity we can find when t is 0. What's your v? Sub v inside. Your v, t 0, v is 8. V is 8, right? So this is 8. Also, when t equals to 7, what's your v? Let's put 7 inside. 7 squared, 49. 6 times 7, 42. 49 minus 42 is 6, right? Sorry, 49 minus 42 is 7. 7 plus 8, you get 15. So this is 15 here, right? All the way. I don't have to draw all this dotted line. I don't have to. Oh, my graph is done. But one more thing. Determine the range of values of t when the velocity is increasing. Well, you can see a velocity is increasing here. Basically, velocity is increasing when your a is more than 0, right? Yeah, you can write this a more than 0 if you want. So t, you can see based on the graph, right? Velocity is increasing when t is more than 3, right? From this part onwards, velocity is increasing. All right, we are done with this summative practice. Yeah, I hope it has been a good learning experience for you. All right. Yeah. Oh, and if you enjoy this video, yep, and you like more to find out more about our books, I've written a lot of modules, 100 modules for maths, and all that. So here we have the notes and tutorial series, topical practice, intensive revision, passive question, passive practice, through practice book. Yeah, get in touch with us. Yeah, through WhatsApp, call us, find out about more about us on our website, our Instagram and Facebook, right? So some of the books are written that includes this topic of drill practice on board. Just show you an example of drill practice. Some students may prefer to have, a question with example and increased level of difficulty, which I already designed such way, right? Step by step, the increased level of difficulty. So these are some of the example that we have. Yeah, the question we have. And the best part is it comes with a complete solution. Yeah, that is a complete solution for you to refer to. Please got stuck doing the question, you can check. You can find out from more about this also from our Shopee page. Yeah, just find Who's Tuition Ability, you can find us, right? And yeah, there's a lot of books that we have available for you guys. Thank you for watching this video. I hope to see you in the next one.